Okay, we should all be here at 2.6. That's where we need to start off. We're going to talk in this next section. We're kind of going back to like function notation a little bit. We're not really going to be focused so much on the graphs. We're more going to be working with functions and doing what we call composition or combination of functions. So this is when you're maybe given an equation or a function that's kind of written out in that notation, and they're going to ask you to either just evaluate points at the function, or they're going to give you multiple functions and they're going to want us to start plugging this function into this function, or vice versa. And so we're plugging in like a whole other expression for x. So you may not get an answer that just says like 5 for your answer. You might get a whole new expression that we then could evaluate if we had points. So we're going to talk about how to do that. We're also still going to talk a little bit about finding domain. So mainly looking at what x values would cause issues. And we've done a little bit of this before when you guys have equations that have like fractions involved. You have to look at the denominator. What would cause an issue in the denominator? That's going to cause restrictions on your domain. Okay? So if we take a look at this first one, I'm just going to go through first how you would talk about domain. So my function here says g of x equals 5x over x squared minus 49. The first thing I would do is think about, can you factor the bottom? This is one of those special cases. This is a difference of two squares. So do you guys remember how this would factor on the bottom? X minus 7 and x plus 7. Okay? So when you kind of like break that apart, you can see now if I were to set each of those equal to 0, so x minus 7, if I set that equal to 0, or x plus 7 and set that equal to 0, I would get two different answers for x. I would get a positive 7 and I would get a negative 7. What we've talked about in the past is when you're dealing with a graph like this, if I was actually going to try to evaluate at 7 and negative 7, I wouldn't be able to do it. Like if you type something like that into your calculator would give you some kind of error message because it's not going to evaluate something divided by 0 because it can't. And so that's kind of what's going on here. Is I can't divide by 0, so I have to exclude those values from my domain. Now what they're showing you over here is just a different way that they found those exact same two numbers. They didn't think about factoring. They just decided, I'm going to take that entire denominator, set it equal to 0, and solve it. So they move that 49 over and then they square rooted it, but you still get positive and negative 7 like we did. So really either way works. But now what we have to think about is, how would I write my domain? I can't have 7 and negative 7 working for my numbers. Like those would be your excluded values. So they write out your domain right here. I could have anything that's smaller than negative 7. So that negative infinity is representing anything to the left of negative 7 would work. And then when I get to negative 7, that causes an issue. So I have to put parentheses around negative 7. That just means I can't actually evaluate at negative 7, but I could get really close to it. So I could get as close to negative 7 on either side. Then it's the union, because this is more than one set of x values that works. It could be anything between negative 7 and positive 7. Again, not including those two values. That's what those parentheses like are marking for us, is that we're not actually using 7 and negative 7. And then the last one is anything by 7 up to positive infinity, because anything bigger than 7 would work as well. They won't always be like 3. Sometimes you'll only have 2 things that you write for your domain. Sometimes it might just be 1. It kind of just depends on what's happening in your denominator. So if you guys look at this next one, what would be a value that would cause an issue? What can x not equal if you just focus on the denominator? If you just set that equal to 0, you get just 9, right? It doesn't have negative 9 in this one because it's not like a squared situation, and it's not got 2 pieces here. It just has the 1. So the only number I can't have is 9. So if I were to write out my domain, I could have anything smaller than negative 9. So we would represent that with negative infinity. And again, we always have parentheses around negative infinity because we can't really define what infinity is, because it goes on forever and ever. And it could go up to 9, but it can't equal 9, so it has to have parentheses. And then I would write union. How would I write the other side? Yeah, 9 to positive infinity. Because again, I can't have 9, but I could have like 9.1 or 9.2, and then I could even go all the way up to infinity. I could put in 100 or 1,000 or 1,000,000 for x. Okay, if you guys go to the next page, we're going to talk now about how to combine functions. And we'll still want to maybe consider any impacts that we have with the domain. Usually the only time you'll have restrictions on your domain is when you have a fraction involved, because that's when you have to think about dividing and like issues that would arise with that. Or if you have like weird symbols like square roots or things like that, anything that would maybe cause an issue. Most of the time though, if it's just like a standard equation like x squared plus an x plus a number, there won't be any restrictions on what you're putting in. Now this is kind of showing that when you have things written out either separately or combined. So this is just kind of showing you the difference in notation. Like if we had f plus g x, and like f plus g is together in a set of parentheses and x is next to it, that is the same thing as adding those two separate functions together. And they do that exact same notation for subtraction, multiplication, and for division. And again, you can kind of see here on the division one, this is when they're saying, you know, the denominator cannot equal 0. So that's when you'd have to start thinking about restrictions on your domain. So let's get into working with these. We're going to start by just looking at the two functions that we have. We have f of x equals x minus 1, and we have g of x equals x squared minus 1. The first thing they want us to find is just adding f and g's functions together. So we're just going to bring down f, which is x minus 1. We're going to bring down g, which is x squared minus 1. And we're going to add these together. So I'm just going to put a plus sign in the middle. And then I'm just going to look for like terms that I can combine. And I always think about descending order. So I start with the largest exponent first. So I see an x squared. Is there any other x squareds that I could put with that one? No. So I have to just bring that one down. I see an x, but only one of those. So I'm going to bring down the x. What about the -1 and -1? Can you put those together? What do you get? -2. So this would be your simplified function by adding them together. And then the domain, because there's no fraction, there's no division happening here, I could put in any number I wanted for x. So there's not going to be any restrictions on my domain. I'm just going to write -infinity to positive infinity. What was that? Okay, f minus g is the second one. So very similar to what we just did. I'm going to bring down those two functions. So f is x minus 1. And then minus my g. And I am going to put parentheses around this. Do you guys know why I'm putting parentheses around it? That minus sign has to go to both terms here. So it's maybe important to remember that, because you don't want to just subtract the first, like just make the first one negative. The second one is also going to change its sign because we are subtracting. So this really says x minus 1 minus x squared plus 1. If you combine those together, what are you left with? Negative x squared. Plus x. Is that it? Yeah, what happens with those ones? They cancel. They're gone. Am I dividing at all on this problem? No, so my domain is still going to just be -infinity to positive infinity. Because I could put in anything for x and it would be able to be solved. Okay, what operation are we doing on the next one? Multiplication. So when you multiply, I would put them in parentheses because you're going to have to think about like either foiling, or if they're really large polynomials, you'll have to think about maybe using the box method or doing like a lot of distributive property. Like you'll have to kind of figure out which way you want to go about it. But if I'm taking f times g, that would be x minus 1 times x squared minus 1. So I'm just putting them side by side. I would honestly, for this one, probably just FOIL it. So if we FOIL, what does my first term say? X cubed minus 1 x, right? Because outside would be x times the negative 1. So I'm just going to write minus x. What would be your inside terms? I'm not going to write the 1 if that's okay. And then negative 1 times negative 1? Positive 1. The only thing I would suggest you guys do is write it in descending order here. So I would just switch those middle two terms around. It looks better if it's written in descending form. What do we think the domain would be here? Yeah, negative to positive infinity. Again, I don't see a fraction, so there shouldn't be any restrictions on x. Okay, last one though is dividing. So we will have to think about that when we get into writing out our domain. But we're taking g divided by x. G was x squared minus 1, and f was x minus 1. Can you factor the top? That becomes x minus 1 and x plus 1. All over x minus 1. Can we cancel anything off? Yeah, the x minus 1s are gone, so what are you left with? X plus 1, okay? But let's think about the domain. You have to think about the domain before you did any of your canceling. Okay, so on the bottom we had an x minus 1 before we canceled it off. So what number would be an issue? 1. So how would I write my domain? Negative infinity to negative 1. Should be positive, right? Because it's x minus 1 equals 0. So the only number it can't be is 1. So it'd be negative infinity to 1, and then what? 1. Good. You got it. Again, we only had to do that on that one because we were dividing, so we have to think about that. And you always want to go back to like the original form before you started crossing things off when you're trying to state excluded values. Especially if there was like a lot of parentheses on the bottom and you're canceling off a bunch, you have to think about all of them before you cancel. All right, do we have any questions on those 4? Everyone doing okay? Okay, if we go to the next ones here, these are having us do composite functions, which means you're plugging a function into another one. So we're not necessarily evaluating at a number, or we're not just like adding or subtracting like what we were just doing. So we have the functions for f of x, it's x minus 1, and g of x, it's x squared plus 1. They're just a little bit different than what we were just working with. And the notation's a little bit different. If you look here, do you guys see how it almost has like this little tiny circle in between f and g? That circle is telling you that you're going to handle this a little bit differently. You're doing the composite function, which means you're taking f of g, which means you're taking g's equation and you're plugging it in for the x that you see in f's equation. So for this one, I'm taking this x squared plus 1, and I'm plugging that in for the x on f. So f starts out as just x minus 1. This is just your f of x. But what I'm going to do here is instead of writing x, I'm going to plug in g. So I'm going to plug in x squared plus 1. That's going to take care of this x. And then I still have minus 1 from my original equation. So I have to make sure I add that onto the end. So instead of writing x minus 1, I'm putting in x squared plus 1 for the x, and then I still have minus 1. What happens here? The ones cancel. What am I left with? X squared, and that would be my answer. And they're not asking for anything about the domain right now, so I'm not going to worry about doing that. Now, the second one is the same idea, but reverse. Do you see how now it says g of f? So we're going to do the opposite. We're going to start with g's function, which is x squared plus 1. And we're going to plug in what for the x? X minus 1. Now, you'll want to be careful here because it's x squared. So in for x goes f's equation, which is the x minus 1, but it's squared. And then I still have plus 1. So you will want to expand out that x minus 1 squared. And if you need to, think of it as it's x minus 1 times x minus 1. And then plus 1. So we'll have to probably FOIL it again and then combine like terms. If you FOIL x minus 1, kind of a shortcut you can do is it's going to be the first term squared, so x squared. Because it's the same quantity that you're FOILing, the outer and the inner terms are going to be the exact same, so you can just double it. So the outer terms would be negative x, and the inside terms would also be negative x. So kind of a shortcut, if you don't want to write those out separately, is you can just kind of think about that and then just know that you're going to double the term. So it's going to be minus 2x. And then we have negative 1 times negative 1, which is 1. And then we still have plus 1. So what does my final answer say? What's the only thing we can combine? The ones. So it's x squared minus 2x and then plus 2. Questions on how we're doing these ones? Okay, so we've got another set down here. We've got 2 new functions. So I want you guys to kind of walk me through. What would you do for this first one, f of g?
Put in g of x for x on the f.
Yes. So f's right now says square root of x plus 2. So what do we put in for x?
X squared minus 3.
X squared minus 3. And then plus 2. And so how would this simplify? Square root of what? And I would just leave it here, guys. You don't need to try to take anything out of the square root there. You don't need to try to factor that or anything like that. Okay. Over here on the other side, you're switching it. You're doing g of f. So you're going to start with x squared minus 3. What is this one going to look like? What are we plugging in for x?
Square root of x plus 2 squared minus 3.
Okay, now this one is kind of already got it built in. We have a square root, but it's being squared. What happens with those? It cancels. So the x plus 2 is going to just pop out, and then we still have minus 3. So what do we have left?
X minus 1.
Good, x minus 1. Okay, so now that you kind of have seen how you would do those compositions, like putting them together, we will also have some where maybe the domain starts to be affected if there's like a fraction involved. So if you guys go to the next page, we're not so much going to be focused right now on evaluating, but more so on if I do the evaluation and then I need to maybe add on the domain piece, what happens here. So we could do these the same way we were just doing those last ones. We could do the whole composition. They're just not asking for that. So they're giving me two functions now, f of x and g of x. You can see how both of them, though, already have fractions involved. So anytime we see a fraction, that probably means we're going to have to focus on the domain a little bit. They're having us do f of g. That's what they have notated right here. Okay, they are already stating that the g function would be undefined at x equals 0 because it's just got an x in the bottom, and that would be an issue if we had a 0 there. Okay, but then they go on to actually show you how they would do the composition. So they put 4 all over in for the x that was on the bottom of f's function. That's where they replace it with g. So that's where this 1 over x came from. And then plus 2. Because there's a fraction, like this is a complex fraction. You have a fraction inside of a fraction. They're reminding you that when you're trying to eliminate a fraction, you have to multiply every term by the LCD, which is x. So that's what they did here. They took this x that was in the bottom, right here, and they took this term times x, and they took this term times x. When they took this one times an x, they canceled, and that's where the 1 comes from. And then 2 times x is just 2x. Okay, so I'll just write that here. They took this times x, and they took this times x. That's how they're getting to this point here. They also have to do that to the top, because anytime we're doing it, it's like an equation. Anytime you do it to one side, you have to do it to the other. Anything you do to the bottom of a fraction, you need to do to the top of the fraction to keep it balanced. Okay, once you get to that point, though, there's really not a lot of simplification that can be done. Like, I can't cross off anything because none of them have everything in common. That one kind of throws it off kilter a little bit. So we have to set the bottom equal to 0, and that's what they're doing here. And so they get x equals negative 1/2. So then they're writing out the domain. So that negative infinity to negative 1/2, that's what we found when we set that bottom equal to 0. And then again, negative 0 or negative 1/2 to 0 because that's coming off of g's function. So they're coming back up here, and what they wrote at this point also plays in. So we're saying x can't equal 0 and x can't equal negative 1/2. That's how they're writing out the domain using those two numbers. Okay, so let's do this now with g of f. So we're going to do the same two functions, but we're going to do the whole process. So we're going to plug in f's function in for g's x. So g says 1 over x. So instead of x here, we're going to put in f's equation, which is 4 over x plus 2. Okay, I want to get rid of that x plus 2 out of that denominator, so we're going to multiply everything by x plus 2, because that would be my LCD. So I'm going to do that to the top, to the 4, and to this x plus 2 down here to get these ones to cancel. I think I wrote that one too many times. Let me get rid of this one, because they should cancel just on the bottom. This should cancel with this. So on the top here, you have 1 times x plus 2, which would just be x plus 2, all over 4. So that's your simplified equation, but now let's focus on the domain. So remember, we have to think about what would be issues before we even started simplifying. So before I had crossed anything off, I had that x plus 2 in the denominator at the way bottom. So if x plus 2 is down here, if I set that equal to 0, that means that my x cannot be equal to negative 2. So then I would write out my domain. It could be anything smaller than negative 2, so negative infinity to negative 2, and then the union with negative 2 to positive infinity. So that's kind of going back to what we started out with. It's just now kind of showing you the connection, where we started, what we have been doing, how you can put those two things together. Last thing is they're going to maybe give you an equation, and they're going to want you to split it apart into the two functions that they maybe used a composition on to get to this answer. For example, if I have the combined equation h of x is saying that it's x minus 7 to the 8th power. I would want to be able to write this out as two separate equations. To do that, one that they thought of was like, if you had something to the 8th power, they could have replaced that x with a new quantity. So they took just this 8 and they attached it to this x to the 8th power for one of the equations. But if you think about an x being in there, that's where that x minus 7 is sitting right now. So that would maybe be the second equation. So you just kind of have to think about what's a power that you see, or maybe like on this next one we have a square root. How could I write that as just like an individual square root of a letter? And then the other function would be what is placed underneath the square root sign or underneath or inside the parentheses when you're raising something to a power. So for example, for this next one, I could take this and say one of the functions, maybe g of x, is equal to just the cubed root of x. Because I see that root sign and I see that it's got a 3 there. And then I could say f of x is that piece that they plugged in for the x, which would be that quantity x minus 9. And so if I think about what happened, they took f's function and they plugged it into g, because they replaced g's x with the x minus 9. And so that would be kind of what they wrote up here. This would be evaluated as g of f. If you switched it, if you said that f of x was the cubed root and that g was just x minus 9, then you would say it's f of g instead. So it doesn't really matter the order you write that in. It's just making sure that you understand how you split it apart or put it back together.